Lesson 3.1, angles on a coordinate plane and coterminal angles. So this starts our unit on trig, and we won't get to all the trig concepts, but it's a good foundation of angles. We're going to talk about the unit circle, and it starts off pretty easy with just estimating angles and creating angles, and we'll talk about what coterminal angles are. Estimate the given rotation within 10 degrees. So what you need to know is our angles will start in what's called standard position, which is where you have the vertex here at the origin of the graph, and then the ray comes out on the x-axis to the right. So that's the first ray of the angle. And then what's happening is it's like you're taking, hands on a clock, you're taking another ray and you're opening up counterclockwise. So as we go counterclockwise, this is going to be the degree of rotation, and it's going to be positive when we go counterclockwise. So no, it's a little bit opposite when you have to go backwards in a clock, but yes, counterclockwise is positive. So what I need to know is that here, if this angle were closed up, this would be 0 degrees. If I rotated it up to here, this would be 90 degrees. If I rotated to here, that would be 180 degrees, a straight line. And then this would be another 90. 180 plus 90 would put this at 270. And then all the way around, if I made a complete revolution, that would be 360 degrees. So remember all 5 of these little, I don't know what you want to call them. They're called quadrantal angles. They're kind of the basics. So anywho, if I open this angle up to here, I'm going past 90. I'm not going to 180. It looks like I'm halfway between 90 and 180, which would be another 45 here. And this would have been 90. So 90 plus 45, I would call this 135 degrees would be my estimate. Number 2, I'm going all the way around, and this is at 270, so I'm even further than 270. Well, halfway, that would be 45, would be here. So I'd say that's another 5 degrees, 6 degrees. You're just trying to be within 10. So let's play it safe and let's say like 276. And I'm not sure exactly what it is. Okay. Then if they're asking you to create an angle, you're just going to take this yellow dot and open it up. 250 degrees would be all the way around 90, 180, almost to 270. So somewhere in here is where it'll stop, and it'll have an opening like this. So I'd call that 250 degrees. They get a little harder than that. Sometimes we have negative angles. Negative angles mean they actually open clockwise. So it's going to go this way 320 degrees. So this would be 90, 180, 270. It's almost back around to a 360. But what I would rather do for my brain's sake is actually add a complete revolution of 360 to this, which would give me 40. I can actually go 40 degrees counterclockwise, my normal direction, which would be what? 45 would be here, so a little less than that. Here is where it could be drawn, but remember I'm opening clockwise. So this whole rotation here would be my negative 320. So just make sure if you're using this trick of adding 360 to it, that's fine to determine where this terminal, this ending ray is, but you're going to have to know your opening actually goes clockwise. Then let's say we have a really big angle, something bigger than 360. That means I'm going all the way around and then around some more. To figure out how much more I'm going, let's just subtract 360 until we get a smaller number that we would know where it's at. So 632 would be minus 360, leaves me with 272. So I'm wanting to make a complete revolution. That's 360, and then another 272 more. Well, 270 was here, so it would be like in here. And the way they'll show that when you go around, you'll go this way. And it stops to there. If I have a negative really big angle, same thing. I just want to keep adding 360 until I get to something positive, because I don't want to make that? Negative 916 plus 360 is negative 556 plus another 360 is negative 196. I'm going to go one more time to make it positive 164. So let's just think about where that would stop. Here's one of them. 164 is not quite to 180. Be somewhere in here. And I'm going reverse. So I'm going the negative degrees. That was 1, 2 times. 1, 2. It'll be easier when you did it on the computer and it makes it for you. But there should have been 2 revolutions. And then this last one I made because I wanted to figure out where exactly that was at in the positive direction. So what you've actually been doing is what's called coterminal angles. It's an angle that has a common terminal side. And I've kind of been throwing that word out. Our initial side is the ray that comes from the origin out to the right on the x-axis, and then the terminal side is just the second ray of wherever it stops or lands. So we're trying to find an angle that would be in the same position as 3 degrees, but we want it to be between 0 and 360. All you have to do is keep adding or subtracting 360 until you get something. So if it's positive, we just want to subtract 360. That's 583. Subtract another 360 because I'm still not between 0 and 360 yet. 223. That does fall between 0 and 360 degrees. So that's all they're wanting, is what angle would actually end at the same spot, kind of like what I've been doing here. I've been having a ray somewhere else, but it's actually in the same spot, whether I go forward, whether I go backward, whether I go around several times, all that good stuff. So on this one, 1050 degrees, you would subtract 360 until you get to something between 0 and 360. 690 minus 360 would be 330, and then I could go on and stop because that angle falls between 0 and 360. So if I were to draw a 330 angle, that would be 30 degrees away from being all the way around. That would be this. That's the same thing as if I were to go around multiple times. I'm confusing myself with the direction. So it doesn't matter whether you go around multiple times or not, it would still stop here at the same terminal ray.